Hello and welcome to my Coursera capstone project. The project is called Classification of Malaria Blood Samples and it's a Kaggle dataset. Malaria is a life-threatening disease caused by parasites that are transmitted to people through the bites of infected female Anopheles mosquitoes. It's actually preventable and curable, and in 2017 there were more than 219 million cases of malaria in 19 countries. And there are quite a few deaths reached in 2017. Malaria is caused by Plasmodium parasites, and these parasites are spread to people through the bites of infected female mosquitoes, which are called malaria vectors. The diagnosis of malaria is commonly done using blood samples and actually blood cells, which are smeared on microscope slides. Prior to examination, these specimens are stained to give the parasites a distinctive appearance. This technique remains the gold standard of most laboratory confirmation, and however depends on the quality of the reagents, the microscope, and the general equipment. So the task at hand was here: can we actually automatically classify blood samples as infected or uninfected? The actual data set involved more than 27,000 images of blood samples of single blood cells, with equal numbers of infected and uninfected conditions. The image sizes varied across the sets, and images generally were saved as PNG files with RGB channels, and cells were photographed on a black background. Initially, I did some data exploration to find a good common ground for resizing these images. So it turns as I mentioned before, these images were actually the image sizes varied a lot. So but they had a common mean around 130 pixels in each direction. As a model choice, I decided to go for a deep convolutional net, as these were, as I mentioned, images with 3 channels RGB, and yeah, and based on my data exploration, 64 times 64 pixel were actually a good choice for resizing these images. I also decided to use a conservative resizing approach, as this would preserve the initial ratios of the actual images without cutting anything away or distort the images. As a performance measure, I first divided my data in training, testing, and evaluation sets, and choose accuracy and loss function and a loss during training of the neural net. And for the evaluation set, which was then based on this 10% evaluation data, I used accuracy and area under the curve and receiver operator characteristics. This is already the model evaluation. As we can see, after 25 epochs, the model converges well to a small loss value, and the accuracy also goes up quickly and stays at around 95% accuracy. The ROC characteristic looks also okay, I think, pretty good even, as the idiot classifier would actually be in the left upper corner, where we basically actually are. And also the confusion metrics with the F1 scores of 69 are pretty okay. So I think it actually worked very well. Thank you.